Okay, this is algebra 2 with trig. We're working on 3b.3a. We're going to solve rational equations. We're using cross multiplication to do that. So you can use cross multiplying to solve a rational equation when each side of the equation is a single rational expression. You must be sure your answer fits the domain. That means that it's possible in the problem. We need to be sure that the denominator is not 0. That's what we need to be sure. Check to make sure that your solution does not create a denominator of 0. So we don't want our answer to give us a 0. So our first one, when we cross multiply, you've done this for years. That's when we take our denominator and we multiply it to the other side. In reality, we'd really be multiplying it to both sides. They would cross out here, and you'd be left with your x minus 2 on this side. Then you'd take your next factor and do it to both sides, which is essentially multiplying there. So we'll say that this is 5 times 2x minus 2. And over here, this is 12 times x minus 2. Distribute 10x minus 10, 12x minus 24. Now notice that there are no fractions. There are no fractions, so we can go right in to just solving like a regular algebra problem. Oh, sorry. And in this case, what I just did, I brought them over to the same side of the equal sign. I don't want to cross it off that way. There's only one type of x to the first power. So I want to be sure to bring things to the opposite sides of the equal sign. So 2x equals 14, divide by 2 to get x equals 7. Now we need to be sure that that 7 is a possible answer. If we plug it in completely, notice we'd get 7 minus 2, which is 5. So 5 over 5 is 1. 2 times 7 is 14. 14 minus 2 is 12. 12 over 12 is 1. So 1 equals 1. Perfect. But that's not really what we're supposed to be checking for extraneous. What we're going to check for extraneous is just how does it affect the denominator? Does it make the denominator 0? And no, it does not. 7 minus 2 is 5. 14 minus 2 is 12. That does not make either denominator 0. So this is a good answer. Again, we'd cross multiply. That gives us 15 times x and 7 times 2x plus 2. Yeah, you could factor out the 2 first, but it's not going to help you reduce anything. So then we distribute. We group our like terms together. We got x equals 14. We look at our denominators. No value of x is ever going to make this equal 0. Make the denominators 0. This is 7. This is 15. They don't have x's, so nothing would be a problem. Letter C, again, we're going to cross multiply. So we get 5 times x plus 2 and x times 2x minus 3. 5x plus 10, 2x squared minus 3x. Oh, look at this one. This one has an x squared in it, and it has an x. You've got two different types of x's. If you have two different types of x's, you need to bring all the terms over to the same side of the equal sign. You need to make it equal 0 on one side for us to solve this. Okay, so now we look at this one, and we notice that there's a GCF in here. There's a common factor in here. So just in terms of factoring, maybe that would help us limit our factoring options. Pull that 2 out. Now, could you divide it out? Yes, we're going to get rid of it. It doesn't matter. It's insignificant in the solving aspect of this. So we get x and x. We get 5 and 1. It multiplies to be -5 and a +1. That'll multiply to be -5. That'll add to be -4. Now we're going to use our zero product property. So we get x equals 5, and our zero product property to get x equals -1. We don't need to set 2 equal to 0 because 2 does not equal 0. When does 2 equal 0? 2 never equals 0. 2 is 2. So that's really irrelevant. So we get our answer of 5, and we get our answer of -1, and neither of those answers will give us a 0 in the denominator.
Mr. Weber.
Okay, with letter D. Now, D has a polynomial, quadratic to be exact, that can be factored apart. There's really no big reason to factor it apart because we're not trying to cross it out necessarily with other terms. You could. There is an advantage in there. Let me show you both ways. So first we'll multiply and say p squared minus 3p plus 2. And we'll multiply to get -6 times p and -6 times -1. So we have to bring them all over to the same side. So this gives us p squared plus 3p minus 4 equals 0. So when we factor this, we get 4 and 1, +4 and a -1. That's going to give us p plus 4 equals 0 and p minus 1 equals 0. This is the zero product property. We get -4 and we get +1. Now here's your experience of taking the p equals 1 and plugging it in. 1 minus 1, that gives us 0. Oh, that's an extraneous solution. That's an extraneous solution because that made the denominator 0. It actually would make it 0 in both of them, but that makes it 0. So this was kind of option 1. That was one way to solve it. Option number 2, another way to solve it. Another way to solve it is to look at it as two different factors, p minus 2, p minus 1. Just another way to do it. If you would cross multiply and bring that p minus 1 up here, you'd bring that p minus 1, those would cross out. Then you would cross multiply and say p minus 2 equals -6. Add the 2 across. And you just get the -4 like we had there. You never even see the extraneous solution. So sometimes you can get rid of that extraneous solution. It will actually save you steps. You don't have a quadratic to factor. It saved you so you didn't have to deal with the extraneous. Sometimes we don't notice it. Sometimes we're just doing the math and we come up with an extraneous, and that's what we get. We don't throw a fit. All right. Okay, example E. So again, we can do our GCF. There is some factoring in here we could pull apart, but it doesn't seem to really help us out. Gives us an X. Oh, that would be X minus 2, but it can't cross out across there. So we get X and 2X minus 5, and we get 3X minus 6 and X minus 2. So even if we factored that apart, we'd have to multiply it back together. So we get 2x squared minus 5x, 3x squared minus 6 is negative 12x plus 12. So we got different types of x's, so we're going to move them over to the same side of the equal sign. We got 0 and x squared minus 7x plus 12. So if we factor this apart, we get x and minus 4 and minus 3. So x equals 4 and x equals 3. Neither of those give us 0 in the denominator. Neither of those would be a problem for the domain. All right. So the flip side, now we're down to a few that you can try. And then we have a story problem. Let me jump down to the story problem real quick. Okay, it costs a manufacturer $50 to make a tennis racket. If the initial investment in the product line was $25,000, so it cost $25,000 to buy all the machinery to make a tennis racket. How many tennis rackets must be produced before the average cost falls to $75? Well, if we know that X equals the number of tennis rackets made, that's what X stands for, number of tennis rackets made, we're going to say that it's $50 for every X, for every tennis racket made. and it is $25,000 total, regardless of the number of tennis rackets. So there's no X that goes with that. It's definitely not per tennis racket. And we're going to to find the average, we have to do your total cost by the number of items. Total cost by the number of items, which would be the number of tennis rackets. And you want this to equal $75. Now it turns into a math problem. You like to put that over 1 so you can cross multiply. You're welcome to it. So you get 50x plus 25,000 equals 75x. And we divide by the 25. And that gives us 1,000. So what that 1,000 means is we have 1,000 rackets to have an average of $75 each. So that'll cost the company $75 at an average. So now this is where the company decides to sell it at $150, $225 to buy this tennis racket to help compensate for those prices a little bit quicker. And as soon as they hit 1,000, then they can really start to discount that. And then they go ahead and make the new model that has a little bit more bells and whistles. That's business. All right, these three. All right, I'd suggest to pause the video, run through these, give it a try, and then see how you did. So here, this is two fractions that have an equal sign in between, so we would cross multiply. We'd have to distribute. Then it's just the normal two variables, or a variable on each side of the equal sign. And we divide by 5. We figure out that x is 10. And 10 does not make our denominator 0. So we're good. Cross multiply. Distribute our numbers in. Oh, I see I made a mistake. This is supposed to be 2x. So that would be 2x times x is 2x squared. And 2x times 1 is 2x. So I got to change this up a little bit. Sorry about that. Actually, 1 is one of our answers, but we missed the other answer. So we're going to subtract the 20x over and add the 16. Now, in this case, we had to bring them all over to the same side of the equal sign because we had two different types of x's. We had an x squared and an x. So this is a quadratic with a b term. We can pull that 2 out or even divide everything by 2 if you want. If that helps you factor it apart. So you get x equals 8 and x equals 1. Neither of those answers give you an extraneous solution. When you plug those numbers in, 1 plus 1 is 2. That's not 0. -1 would give us an extraneous. But we don't have -1. We have +1 and 8. 8's good also. Last one. So we got our x squared plus 4x. Distribute through. Don't forget to distribute it to the 4. Don't place a 4 there. You got to be 3 times 4. So this becomes x plus 4, x minus 3. So you get x equals -4 and x equals +3. Look at the -4. The -4 would give us an extraneous solution. -4 plus 4. So this one gets a light x through it, and we call it extraneous solution. If you notice, we could have factored this one x and x plus 4. When we brought that x plus 4 over, we could have eliminated them. We would have never have seen the extraneous. But since we didn't break it apart and see those reducings, it still comes up as an answer that needs to be removed. All right. Good luck, everybody.